Okay, so let us start with alcohols first. So alcohols, what are they? They're often referred to as a central functional group because all other functional groups can be obtained from alcohols. So alcohol is basically one of the most important groups. That's the reason it's been referred to as a central functional group. Okay. So now coming to the oxidation state of alcohol. So alcohols are more oxidized than alkanes, but they are less oxidized than the corresponding carbonyl compounds such as ketones and aldehydes. So what does it exactly mean? So in the presence of an oxidizing agent, it is possible always to change the alcohols into a ketone, aldehyde, or carboxylic acid. Try to understand what I'm saying. If there is an oxidizing agent, so an alcohol can be changed into a ketone group, aldehyde group, or a carboxylic acid group. So this is a possibility. So its structure changes when you have an oxidizing agent. So primarily it is alcohol. So addition will change it to a ketone, aldehyde, or carboxylic acid. So now, as mentioned just now, oxidizing agents. So what exactly we mean to say when we talk about oxidizing agents here? So for example, if I say the first one is chromium, which is a reagent which is used for oxidizing. Then we have KMnO4, potassium permanganate. Then we have HNO3. So what are these? These all are classified under oxidizing agents. Okay, understood the point? Primarily. Then we have secondary alcohols, which always will produce ketones. So after this, the next one is called as secondary alcohols. So what exactly are these secondary alcohols? So they first of all produce ketones. Okay. For example, chromic acid is one such common reagent which is used to carry out oxidation of alcohol. So chromic acid is one reagent. So what can this do? This is actually used to carry out oxidation of alcohol. For example, if I have a secondary alcohol which will look like this, okay, so this exactly is a secondary alcohol. Now, in the presence of a reagent, what could be the reagent? Can be sulfuric acid, for example. In the presence of this, okay, then it might now change to a ketone group. So secondary alcohols, they actually have this tendency of producing ketones when they are actually, you know, use chromic acid, for example, is one of the common reagents to oxidize an alcohol. Okay, so chromic acid, or let it be sodium bichromate or potassium dichromate, whenever these reagents are dissolved in an aqueous acid, like for example chromium acid, then it actually oxidizes it. So that is the reason it is called as an oxidizing agent. So when we say primary alcohol, even primary alcohols will also be oxidized by chromic acid. Understood? That is one such substance. And here, an aldehyde is first produced and reacts further to give corresponding carboxylic acid. Okay, so here I can even represent this with a diagram. For example, this will look something like this. For example, if I have a cyclohexane structure, so it's something like this. So what exactly can this be called? It is called as cyclohexyl methanol. Okay,
How do
so
you know
this
that?
cyclohexane methanol, because we have CH2OH, all the rest are carbons attached to it.
Oh,
Okay,
right. Okay,
so
that
then
makes
I can
sense.
call it a cyclohexyl methanol. Now, if I use a reagent here, like for example, I use sodium bichromate or even sulfuric acid, okay, then this will now change to cyclohexane carboxylic acid. Understood the
So
point
it
here?
went from
Yes,
cyclohexane
exactly.
methanol to
So
carboxylic
here,
acid.
yes, an aldehyde is first produced here, and it further reacts
Wait,
to
is this
give.
tertiary?
Yes, it's primary.
Okay.
Okay. So how will
Oh,
this
this
look
one's
like?
primary reaction.
Yes, yes, these are all primary alcohols. So here again, I'll have a cyclohexyl structure. So this, I have a carbon, and here I have a double bond of oxygen, and here OH. So what I'm going to call this cyclohexane. Okay, cyclohexane carboxylic acid. Okay, and so here chromic acid is also too reactive. For example, an aldehyde formed cannot be isolated. That means you cannot remove it. So that's the reason it is forming a carboxylic acid. Now, one more example for instance, primary alcohols can be oxidized to aldehydes using a less reactive oxidant. So again, in this case, I'll use a primary alcohol, okay, and in the presence of an oxidizing agent, like for example, if I have a chromate CrO3, okay, so that actually can change to an aldehyde group. So try to understand here, okay, as in the beginning I said that secondary alcohol will always produce ketones. Now, this example where we have primary alcohol, it can produce carboxylic acid or it can also produce an aldehyde. Now,
So does that mean the primary just went into, or does it stay a primary, or does it go to like
exactly.
a tertiary?
Yes, no, it stays primary.
Oh, okay.
Now, talking about the
And so
next
I don't
one.
get it. In secondary, it produces ketone and it's a chromic acid.
Hmm,
So a secondary alcohol can be transferred to a ketone,
mhm,
but in a primary, it just changes shape.
yes.
Oh,
Now, coming to
okay.
the third one, that's tertiary alcohol. Now, tertiary alcohols cannot be oxidized to a carbonyl compound because to break one of the carbon bonds, okay, or how do I put it? I can say that tertiary alcohols cannot be oxidized to a carbonyl compound as it involves the breaking of a carbon bond in the process. So, a CC bond, a CC single bond, okay, is required, okay, to break out to form a carbonyl compound. So tertiary alcohols do not have the capacity here. So there is no oxidation possible here in this case.
Okay.
Okay. So this is one particular theory. Apart from that, alcohols that can be used as nucleophiles or electrophiles. Now, when I say a nucleophile, for example, so alcohols they have a lot of versatility.
So are
Okay.
you recording?
Yes, it is.
Oh, okay, right.
So, oh, my camera is switched off. Okay. So alcohols, they are highly versatile. Okay,
Yeah.
because of it's a very good solvent that can be used for many purposes. So it can be both an electrophile or a nucleophile in organic reactions. So, what exactly we are trying to say here? Alcohols can be used as a weak or strong nucleophile, which comes as a natural reactivity of alcohols. Okay, because suppose if you have a weak nucleophile and
Yeah.
alcohols require a strong electrophile to react, and if you have a strong nucleophile, then alcohols can react in many different reactions. Okay. Now, when I talk about the electrophile, alcohols are considered weak because the hydroxyl group is poor leaving group. When I say poor leaving group, so here an hydroxyl group must be transformed into a good leaving group prior to reacting as an electrophile. Okay, this might sound a little bit bizarre when you actually hear it. Okay,
Yeah.
I'll try to show you an example here. For example, no, they haven't taught you any of this.
Oh, well, not that I remember. My friends had to do it themselves as well, so I've got no idea.
So here's a weak electrophile, for example. Okay, then so bromine is given out that actually forms an OH.
So is there any math that I'm gonna encounter, or is
No, no,
it
not
just gonna
not at
be
all,
like,
not at all, not at all. I don't think there's going to be
oh,
any maths here. So we'll be getting Br plus H2. This is one example. Now, apart from this, in when you talk about organic reactions, there are reactions like substitution reaction. So when I use the word substitution, what does this mean? Okay, so when I say something like a substitution reaction, for example, so what exactly happens here? So here in this kind of a reaction, now which is same as a single replacement reaction in organic reactions. Okay, so
yeah,
here in this reaction in which one or more atoms in a molecule are replaced with another atom or group of atoms. Like
okay,
for example, an alkyl halide or halides are formed by the substitution of an halogen atom for a hydrogen atom. For example, let me write this reaction over here. I have CH4, which is in a gaseous state, and this combines with chlorine, which is also a gas. Now, this is happening
okay.
in the presence of maybe UV light. So then, what are we getting here? What will be the reactants now? Here it's very simple here. Now I have four hydrogens, okay, and I have two chlorines here. So straight away there's a reaction going on between CH3 and Cl, and one hydrogen which reagents from this methane goes and combines with one hydrogen to form
HCl.
hydrogen chloride. Understood? So here what has happened here is there is some kind of a substitution that has taken place. So try to understand. CH4 became CH3, and that CH3 combined with one chlorine, and this hydrogen which was left out from here because it was CH4 that became CH3
Is
and
it
combined with chlorine.
CH? But
Now it
then
is
there was,
CH.
oh, there was two chlorines. Never
Yeah,
mind.
yeah. So one hydrogen and one chlorine, they attach themselves to become hydrogen chloride.
Okay,
Okay, which is in gaseous state. Okay. Now try to remember hydrogen HCl. If it is in gaseous state, you will call it as hydrogen chloride. But
okay,
this HCl, if it is in liquid state, we call it as hydrochloric acid. Composition is same. In gaseous state, you cannot call it as an acid. You have to call it as hydrogen chloride.
okay.
Understood? So what exactly
Hmm.
happened here? Now the entire reaction, if you see, two things. Okay, one is of course the reactants, and the other is the products. Okay. So what are the products that we actually got here? Chloromethane and hydrogen chloride.
CH4. Yeah.
Okay.
Oh, yes.
So Now, if I carry this reaction a bit further, okay, so when I say a bit further, I'll take CH3Cl and again combine it with chlorine. Then what do I get? So one more substitution that takes place here is CH2Cl plus one hydrogen combines with chlorine here to form HC.
Why can't we have two HCls?
Pardon me?
Why can't we just have two HCls?
So then it's not a
Why
balanced reaction, right? See, how many chlorines are
why would it
present
not
here?
be? Because you just
No,
have to take one extra hydrogen off.
no, but it doesn't combine because we again have carbon and hydrogen here. Okay, so it has to satisfy this octet configuration formation here.
Oh, right.
Yes.
Okay.
So out
That
of
makes
these
sense.
three hydrogens, one hydrogen combines with one chlorine to form hydrogen chloride, and the
Yep.
other one is CH2Cl2. Now,
Okay.
so the product above is we have if you look at the product side, it is CH2Cl2. So it is a
Yeah.
so it can be called as dichloromethane. Okay.
Okay.
Now, what he says here is further if we substitute, further substitution products could be trichloromethane, tetrachloromethane, or it can be called also commonly called as carbon tetrachloride. Okay, understood this point. So we can have one
Mm-hmm.
more example here for substitution. Like what it says here is chlorofluorocarbons are produced by reacting chloroalkanes with HF, hydrogen
Okay.
chloride. Okay, so for example, if I take a chlorofluorocarbon, so the example here would be CCl4. Okay, this if it is made to combine with HF, it is also a gas. Okay, in the presence of a catalyst, then what forms here? So CCl4, so CCl3 substitutes and then combines with fluorine, and I have one hydrogen and one chlorine still left, and that actually forms hydrogen chloride. Okay, so the fluorine atom substitutes for a chlorine atom in the reaction. Try to understand. Fluorine
Okay.
substitutes for a chlorine. Understood? Because it was HF on the left side, isn't it?
Mm-hmm.
You see here it was HF. So as I said, the fluorine substitutes for a chlorine atom. So if the fluorine goes away from here, so what is this fluorine getting replaced or substituted with? A chlorine to form HCl.
Yeah.
That is the reason we are calling these kind of reactions as substitution reactions. Substituting, it's getting replaced with something else.
So how does this have anything to do with secondary
Not
testing?
exactly with secondary. You will find these
Uh,
kind of reactions taking place over there.
but then these don't have any alcohols, do they?
No, not really. But they can involve these kind of reactions as well.
Oh,
Okay.
okay.
So now coming back to primary, secondary, and then tertiary alcohols. Okay. We'll again go from the beginning. So primary, secondary, and tertiary alcohols, how are they named as? They're named according to the number of carbons directly attached to either carbon or hydroxide carbon. Okay,
Okay.
so this type of a carbon is actually sometimes named as carbonyl carbon. For example,
Carbonyl carbon.
yes.
Okay.
Let me get back to that first. I'll just show you an example here. So, how exactly a primary alcohol might look like.
Sorry, sir. Give me one moment.
Yeah, sure.
Yes, sorry. Yep.
So here C and OH carbon attached, they are attached to one carbon atom. Okay, here
Yes.
one C and one OH. Now the secondary alcohol will have C and OH attached to two carbon atoms.
Yeah.
So the example will be more or less the same, but here you'll have another CH3. So it's basically like this. And even here you'll have a CH3. So secondary alcohol somewhat looks like this. So this is a secondary alcohol. So if you look, C and OH carbon are attached to two carbons. Okay. Now the third one, when we say tertiary, C and OH carbon atoms are attached to three. So they basically will look like this. CH3, here we have a CH3, here we have a CH3, here we have an OH. So this basically is a tertiary alcohol. Understood?
Mm-hmm.
This is how it actually basically looks like. So likewise, you'll have primary, secondary, and tertiary amines as well. Okay, then we have methane and again methyl groups based on this. Then we have amides, which are primary, secondary, and tertiary as well. Okay, so here you understood basically like what exactly these are.
Okay. Wait, there's no different. Oh, wait, there is just a structure. CH3 is alcohol.
CH3, only CH3.
Oh,
How?
wait, what's alcohol's thing?
C and OH, basically.
CNOH.
Yes. So when we talk about primary alcohol, these alcohols are those where the carbon atom of the hydroxyl group is attached to one single alkyl group. So that's the reason we call it as primary alcohols, which are like, methanol, propanol, ethanol. So here the
Okay.
complexity of this alkyl chain is unrelated to the classification of any alcohol considered as primary.
Okay.
So here basically it has only one linkage, which is the OH group. So that is what. So
Yeah.
in that entire alcohol, you will find only one OH group. For example, if I give an example of ethanol, 1 second. So what is ethanol? CH3, CH2, and this is OH. So in primary
Yeah.
alcohols, you will find only one OH group.
Okay.
Understood? One OH group. That
Okay.
too. What is saying existence of only one linkage among the OH group and an alkyl group. That's it.
Right.
Okay, so that
Okay.
is what will actually qualify as an primary alcohol. So when we talk about secondary alcohols, these are those where the carbon atom of the hydroxyl group is attached to two alkyl groups on either side. Try to understand. Here the
Yeah.
carbon atom of the hydroxyl group is attached to two alkyl groups on either side. So how do they look like? So if I have CH3, I have a CH, again I have a CH3 here, and then of course the alcohol group is here. This is a secondary alcohol.
Yeah.
So why it is a secondary alcohol? If you can identify it, two alkyl groups are present or either structurally identical, okay, and here they are on either sides. Which are the alkyl groups? Here we have this CH3 and CH3. They are
Yeah.
on either side, and we have again the alcohol group OH. So that is the reason we are going to call it as a secondary alcohol here.
Okay.
Understood the point? So even if I give you another example, CH3, CH2, again CH, then CH2, then CH3. Now if you see CH3 and CH2 are symmetrically, they're on both the sides of the CH group, and now this CH
Mm-hmm.
is attached to an alcohol here. Okay, so this is also an example of secondary alcohol group.
Yeah.
Understood? Now the third one, of course,
So,
is tertiary alcohol. So what do you mean by a tertiary alcohol? So here we will be having three alkyl groups which are connected to the carbon atom. So how can I represent this? So for example, if I have a CH3 here and I have a CH, here it's another CH3, here's the third one, and here I have the OH or the alcohol group. Understood the point here? So try to get this. So here, if you see a hydroxyl group is attached to the carbon atom, which is again in turn connected to three alkyl groups, two on either side, one at the bottom. Okay, and
mm-hmm.
here the presence of OH allows the alcohols in the formation of the hydrogen bonds with the neighboring atoms. So that's the reason the
Okay.
bonds formed here are not as strong; they are weak, and that makes the bond making the boiling points of alcohols higher than in alkanes. Understood?
Yeah.
So this is how primary, secondary, and tertiary alcohols are classified. So
Okay.
now they might even ask you like uses of alcohol. So it's not just one; they have multiple uses of alcohols. Like first one, of course, it is consumed as a beverage. Okay, but
So,
not
like hand
directly.
sanitizers, cleaning products.
No, it's first of all it is consumed as a beverage where the content of alcohol in that beverage might be roughly around about 30 to 40%.
Yes.
But exceeding that may again be lethal, can cause death. Okay.
Oh, yeah.
Yes. Apart
But
from
it's
that,
not pure alcohol, is it?
no, the beverages what you get outside in the mart, they are not pure alcohol. No way. A
Yeah.
person cannot consume it directly. I mean,
So
it's
does
dangerous.
alcohol only come in the liquid state?
Yes.
Okay.
So, so whatever like you get in the wine stores, for example, okay, liquor stores, they are all in a dilute form.
Yeah, that's what I
So
thought.
if you like name them, for example, there's so many alcoholic beverages. Like for example, you talk
But I
about
know that
beer,
the highest that you can go is probably around like 40.8.
40%.
Yeah.
Okay, now if you talk about some
40% something like
yes,
that.
uh, beverage like a beer or a beer
That's
or wine,
seven
they
point
contain
something.
yes very minimal percentage of alcohol. Now as you go on higher and higher, okay, the
Yeah.
names do change. Okay,
Yes.
okay, with the percentage of alcohol in that.
Yeah, I
Okay,
guess that does depend.
yes,
But okay. And then there's like they use it for like mainly cleaning products, don't they? Like in
they
the
are used as well.
market.
Yes, they are also used as anti-freezing agent when it is mixed with some kind of solution like ethylene glycol dissolved in water. Okay, it can be used as an antiseptic agent as well.
Yeah.
Yes,
Don't they use it in needles to clean
they
before?
can be used, and some alcohols they can be used as fuels. Okay, in internal
Yeah, is
combustion
alcohol in
engines.
fuels? Because
Yes,
they're
like
so
methanol.
flammable, right?
Yes, in methanol.
Oh.
Methanol is a fuel. Okay.
So is that why it's so flammable? Because it's a
Yes.
oh, okay.
And when you talk about the field of medicine, okay, few of them are also used as preservatives. Okay, to preserve
What does that
different
mean?
substances. Yes, to preserve a certain kind of a substance, not allowing them to decay or decompose. It can be mixed with alcohol and then it can be preserved. Okay, many
Okay.
different kinds of medicines also are made using alcohol as a base. Okay,
And yeah, I'm pretty sure like some numbing things are probably like yeah, like most of the drugs are made from a base.
yes, it is. They
Oh.
are made.
But what's the point of adding alcohol into the drugs? Because if that's gonna mess up your brain.
No, you're not taking them in such a huge quantity where the nervous system, begins to get disturbed. Not at all.
So then what's the point of putting alcohol into the medication then?
No, it
Or
has got
what's
several
like,
uses as well. Now, for example, if you talk about alcohols being used in medicines, for example, have you ever heard about um, homeopathy medicines?
yes,
You know what is the base there?
alcohol? Like homeopathic medication is like
Yes.
not in the market
So,
or
when we
some,
talk about alcohols being used in medicines, okay, first thing is uh, it has a good solvent property.
okay,
Talk about solute and solvent, right? So it can actually dissolve many different kind of substances.
yeah,
And secondly, in the medicine itself, it can be used as a sedative. It can be used as an antiseptic. Now, when I say sedative, it can even put a person, calming
to
down.
sleep.
Yes, absolutely.
Oh,
Apart from that, in the earlier days, it was thought that alcohols can contribute to warming and even aiding in digestion.
yeah, doesn't, yeah, most people drink, well,
Yes,
I've heard that
yes,
they'll drink a straight glass of like scotch if they have a cough or something.
yes, they
Yeah.
do. Okay. Now, I'm going to even name, like for example, you must have heard of brandy.
I
Okay.
know.
Yes. So that is one alcoholic drink which contains
Okay.
a lot of healthy antioxidants in it.
Okay.
Okay. And one more thing is, gin and combination
Yeah.
of gin and tonic, for example, it's used in treating malarial infections because it contains quinine in it, which is the first and basic medicine for treating malaria. Okay. And
Oh,
even in most of the cough syrups, you do find alcohol, slight alcohol contained in it. In
because that one
fact,
has like,
yes, many cough syrups and cold liquids which are used for treating, tonics which are used for treating cold. Okay, and these are even, I mean, you can just purchase it over the counter. Okay, so what exactly
oh,
happens here is basically why they use alcohol here is to dissolve certain ingredients. At the same time, it can even preserve that product.
is that like, when you mean by dissolve, do you mean like, for example, if we have like a compound of paracetamol just to make it into the mold,
Yes,
would you use,
yes,
oh yeah, they do that for makeup as well. If you break a makeup, then you
yes,
pour alcohol and
absolutely.
that preserves it as well.
And even
Oh,
cough syrups, mostly they contain around about 10 to 40% of alcohol in that. So that's the reason cough syrups shouldn't be taken blindly without the advice of a doctor. That is the reason whenever the doctors do prescribe syrups to children, they strictly, say that take this cough syrup, 2 spoons or 1 or 2 tablespoons or teaspoons before going to bed, not before going to school.
yeah. Cough syrup
Unknowingly,
will
they
put you
might
to
they
sleep.
might find themselves going into a state of giddiness.
No, some medications will put you straight to bed.
Yes. So
Like
the doctor actually
antihistamines, the
prescribes.
drowsy ones.
Yes. And nowadays,